Hi students, welcome back to the math class. Today we are in the grade 10 mathematics and we are going to learn today's new concept. It's coordinate geometry. See, in this coordinate geometry, first of all, we need to know in that grade 9th. Actually, we have learned it in grade 9th. What is coordinate geometry and who worked out on this one? See, we have learned it on this Rene Descartes. He had worked on this one and he had given one beautiful structure about that like coordinate systems. See, for this one, you have taken two axes, xy axis. This xy axis dividing the total plane into two into four quadrants. Okay, once again, and he named that like quadrant one, Q1, Q2, Q3, Q4, and each one axis is divided x axis and y dash here. Now OX have taken positive and this also positive and this is negative and this is negative. So overall the quadrants are divided into plus plus, then minus plus and minus minus and plus minus. So overall he said the quadrants are Q1, Q2, Q3, Q4 and coordinates it will be in the form of x comma y. Say that first one x is called first coordinate, y is called second coordinate, and the name of x coordinate he named as abscissa, and this one he took it as ordinate, abscissa and ordinate. And based on this abscissa and ordinate, we have learned in the grade 9th standard how to plot it and how to identify the given points in the plane, and also what is the importance of writing x comma y. Everything we have learned in the 9th standard. Now coming to the 10th standard, here in the previous class, whatever we have learned from that only, it is continuation. How the continuation, then we are supposed to find the distance between any two points. Generally, to show the points, we are going to use the capital letters. We have learned it in the earlier class, which is in the 9th standard. Capital letters. See, here A 4, 8, B 3, 9, C 3, 8, D 1, 6, and so on. Now using these points, then we can mark these all the points in the coordinate system. Then we can find the distance between them. And when you are plotting this one, we can find the some different types of shapes also will be formed of. Now here is a given example. A town B is located 36 kilometer east. 36 kilometer east this side. Let us take this is east, north, west, and south. So 36 kilometers east from town A to town B without actually measuring it. Now, what is that? 36 kilometer east and 50 kilometers north to the town A. So 15 kilometers north to town. So now B is here. So now if you want to tell about that two towns with respect to the town A about the town B, if you want to tell from the town A, you have to go east side 36 kilometer. From there, if you that is 36 kilometers, then from there if you take north side 15 kilometers, then there is a point town B. Now based on this one, we can tell about the location of this body of this town will be 36 comma 15, because 36 will be considered as the x-axis value and 15 will be taken as y-axis value. So then the location will be 36 comma 15, and 36 we can take it as first coordinate and 15 will be taken as a second coordinate. And we have learned in the last year 9th standard, and the points which are lying on the x-axis, they will be in the form of x comma 0, and the points which are lying on the y-axis, they will be in the form of 0 comma y. What is that? The points which are lying on x-axis will be x comma 0. The points which are lying on the y-axis, they will be in the form of 0 comma y. So this we have known that. Now, and the points where they are intersecting, the location we are taking as 0 comma 0. 0 comma 0. Now if you are seeing here the point that we need to see here, can you find the distance between A and C? Of course we can find it. First of all, if you take the point A, it is 4 comma 0, and here 0 comma 3. Now I want to find the distance of AC. See, when you are looking this one, it is looking like a right angle triangle. Now, if you see 4, 0 on the x-axis, they are in the form of 4 units distance, and they will be in the 3 units distance. Applying the Pythagoras theorem, this will be 5. So the distance between A and C will be taken as 5 units. Similarly, we can find here in the figure BD also. Same thing. BD, it is 6 units, and here B will be 6 units, 8 units D, and applying that Pythagoras theorem, then we can say what is that? 6, 8, 10. See, like this, using the Pythagoras theorem, then we can tell if you are able to mark the points on x-axis, y-axis. Suppose the points we are unable to mark on the x-axis or y-axis, somewhere is there, then there is a formula how to find it. Look, this is a formula will help you to find the distance between any two objects. Let us assume Px1, y1 and Qx2, y2 are any 2 points in the given plane. Px1, y1 and Qx2, y2 are the any 2 points in the plane. To find the distance between them, P and Q, which is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. Or you can take it we can take it PQ is equal to root over x1 minus x2 whole square plus y1 minus y2 whole square. Please take like this. So this is called distance formula. Okay, Max, remarks. What is a remark? See, in particular, the distance of the point Px comma y from the origin 0 o comma 0 o 0 comma 0 is given by same thing. Let us assume this is x1 y1 and this is x2 y2. I have given you two formulas, either x1 2 1 2 1 1 2 1 2, like this series you can take it off. If you take it, the distance between them o and p will be root over x square plus y square. Now the question number 1, example 1, do the points form a triangle? If so, name the type of the triangle formed. Say, let us assume the points 3 comma 2 and minus 2 comma minus 3 and 2 comma 3. Say, let us mark all these points and join all these points. Now assume that it is forms a triangle. We are not confirmed whether it is forms a triangle or not. Say, let us mark A, B, C. We are supposed to find AB length. Here they are marking as PQR, right? So they are finding PQ, QR, RP, RPR. Say, we know that the given in the 8th standard, if 3 sides are given, whether they forms a triangle or not. See, remember, sum of any 2 sides should be greater than the 3rd side. Condition number 1. The difference of any 2 sides should be less than the 3rd side. Condition number 2. Now, if you add these 2, should be more than. Yes, it is true. If you add these 2, yes, it is more than this one. Or if you add these 2, more than this one. So, sum of the any 2 distance, 2 of these distances greater than the 3rd distance. Therefore, PQR forms a triangle. PQR forms a triangle. Otherwise, they will not form a triangle if they do not satisfy the condition. Now, the question it is that what type of triangle it is formed? Say the types of triangles based on the sides, we know that equilateral, isosceles, scalene. Equilateral in the sense that all the sides of the triangle are equal. Scalene triangle and isosceles triangle, right angle triangle, acute angle triangle. See, now question what type of triangle? Now here, if you see here, they are satisfying PQ square plus PR square is equal to QR square. So by the Pythagoras theorem of converse, then we could say the hypotenuse is equal, square is equal to sum of the other two sides squares. Therefore, they forms a like a right angle triangle. Now, next point, show that the points are the vertices of a square. Say, let us mark all these points. A, B, C, D. Now try to find this length, AB length, BC length, CD length, DA length. AB, BC, CD, DA. All this. Say, remember, if according to the definition of the square, all the sides are equal. If all the sides are equal, then what you could say it is a square and also rhombus. See, there is a difference between the rhombus and square. Property number one will be same. all the sides lengths are equal. Property 2, they will be variated from a rhombus from square. The diagonals, length of the diagonals are not equal. So now, lengths of the diagonals. Say, let us mark AC. What is the diagonal? When you join a line from one vertex to its opposite vertex, it is called as a diagonal. So AC length and try to find the BD length. AC length and BD length. If you are finding this AC length and BD length both are same, then they forms a square. Otherwise, if they're not equal, then it turns to a rhombus. Clear? Next. So now I'm moving to the exercise. Then based on that, I'll try to continue the sums from the other example sums. Wait a second. Now look at the first problem. Find the distance between the following parser points. Okay. Here there are 3 questions in the first exercise, first Roman. Then we'll do 2 questions and other one I'll give you as a homework. Okay, fine. Now the first question, find the distance between the following parser points. Now there are the 3 questions. So first one obviously will be easy. So take it as a homework, this one. And I'm going to do second and third. See now, they're asking to find the distance between that. So let us take 5 minus 5 comma 7 and minus 1 comma 3. So take this one, x1 y1 and x2 y2. x1 y1 and x2 y2. Now we know that formula, distance between any 2 points, d is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. Now please mark all this one, root over x2, which is minus 1 minus of minus 5 whole square, y2 3 minus 7 whole square. So minus 1 plus 5, which is 4 whole square, and minus 4 whole square. So 16 plus 16, root 32. Root 32, we can write it as 16 into 2. So from the root 16, it will be come out, it will be 4 root 2 units. So the distance will be units, we can take it off. So what we have taken x2 minus x1, this and all, you should be very careful to do the calculation. That's all. Then I said you question number B, you take it as a homework. Sorry, question number A as a homework, and we'll go for question number C. Now here also the points. People like these problems are very easy, but when they are looking at the problems, then they'll think of that they don't know. But they are, remember, these type of problems are very, very easy. So one is a comma b and minus a comma minus b. Take that x1 y1 x2 y2. Say same formula. Please take the distance formula. Take that one. Take the formula. See, when you take the formula, then please try to substitute the values which we have known, that distance is equal to root over x2, which is minus a, and x1 minus a whole square minus b whole square. So which will be minus a whole square minus 2a whole square minus 2b whole square. So 4a square plus 4b square. We can take it off 4. When you take it off 4, root 4, which will be 2 into root over a square plus b square units. That's all. This completes the solution of this one. See what we have applied, the distance formula. Okay. Now we are moving to the second problem.
Mera. Good evening.
Now this question, find the distance between the 2 points 0, 0 and 36, 15. Now, if you are going for this one, find the distance between the points. See, take the point 0, 0 and 36, 15. Take the points x1, y1 and x2, y2. So the distance formula, which we know that root over x2 minus x1 whole square plus y2 minus y1 whole square. We have to apply. So x2 minus x1. So 36 minus 0 whole square, then 15 minus 0 whole square. Then 36 minus 0 whole square. So 36 minus 0. So what you could say, 36 square. Then 15 square. So what you could say, 36 square is, which is 1296 plus 225. Now, if you see square root of 1296 plus 225 is nothing but 1521. 1529 is 39 units. Now, he's asking, can you now find the distance between the 2 points A and B discussed in the section 7.2? Right, definitely we can find it. See, let us see for what is section 7.2. One second. Right. See, actually figure 7.2 only I'm taking now. So in this section 7.2, we can find the distance between that A and C. We can find it. Similarly, we can find the distance between B and E also we can find it. So based on these conditions, that what is the distance formula, root over x2 minus x1 whole square plus y2 minus y1 whole square. Using that formula, then we are able to find the distances between that. Next question, we are moving to that one. Next question is about collinears. Now, see, I'm taking this question now. Question number 3. Determine if the points are collinear. See the point. What do you mean by collinear? Collinear stands for if two or more than 2 points. It means 3 or more points lying on the same line. 3 or more points are lying on the same line. They're called as collinear. For example, I'm marking all this one. Now I'm able to draw a line. Now if you see all these 3 points are lying on the line. So in this case, we can conclude that they are all collinear points. Collinear points. Now let us take the question now. What is that? Determine the points 1, 5, 2, 3 and minus 2, minus 11 are collinear or not. Take the points A, B, C, mark. So now we'll find it AB. So same formula, distance is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. So now we are supposed to find AB, similarly BC, similarly CA or AC, because if you are finding CA or AC, no problem, because direct distance cannot be followed any direction. Now, whenever you are taking AB, so you take the points A, 1, 5, and B, 2, 3, take them as x1, y1 and x2, y2. So now we are finding the distance AB. So AB is equal to apply the formula. Root over x2 minus x1 whole square. So which is 2 minus 1 whole square plus 3 minus 5 whole square. See, root over 2 minus 1 whole square, which is 1 square, and 3 minus 5, which is minus 2 whole square. So now what you could say, root over 1 square is 1, minus 2 whole square is 4. So total is 5 units. Root 5 units. Similarly, we are supposed to find the value of BC and CA. Okay. So similarly, I'm going to take the values of B and C. Say I'm taking B, which I have taken from the top, 2 comma 3, C minus 2 comma minus 11, which is x1 y1 and x2 y2. Now same thing we are supposed to do that BC. Apply the formula same, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, now say what you could say, minus 2 whole square minus 11 minus 3 whole square. So now what you could say, minus 2 whole square minus 4 whole square, which is 16. Then minus 11 minus 3, which is minus 14, minus 14 whole square, which is 196. So these calculations we should be thorough. Then these problems will be easy. Otherwise, this problem will be think like it is too difficult. So now square root of 16 plus square root of square root of 16 plus 196. People have a tendency they will take it out 16 out, they will do for 196. It's wrong, quietly wrong. So 16 plus 196. So 16 plus 196, which is 212. 212. Say we can write it as 4 into 53. Say we can take it out 2 out because square root of 4 is 2 root 53. 2 root 53. Then we'll go for AC. C for minus 2 comma minus 11. And A stands for 1 comma 5. Now same way, x1, y1. And x2, y2. So now I'm going to find same AC or CA. No issue. Whatever the way, if you are taking AC or CA, the answer will become. Now minus 2 minus 1 whole square. Plus minus 11 minus 5 whole square. So now minus 2 minus 1 whole square, which is minus 3 whole square. Minus 3 whole square is 3 square is 9. Then 11 plus 5, 16. 16 whole square, which is 256. Which can be root over 265. Root over 265. So square root of 9 plus root 256, we are getting root 265 square units. Now, say actually we are learning the collinear concept as more than 3 or more points are lying on the same line, they are called as a collinear points. But when you are coming to this problem that we are not going to points, we are thinking about the distances. Then from these distances, how you can connect their collinear concepts. See, the collinear concept is very simple here. See, I'm telling you, sum of any two distances in this, which is equal to third one. Sum of any two distances or magnitude, which is equal to third distance. If it is happen, sum of any two distances happen to that third distance, then what you could say, they will be satisfy the condition of collinear. Now, look at this problem. Now, whether AB plus BC, you take AB and BC. AB is root 5 and BC root 2 into root 56. See, sum of these two, AB plus BC, for example. See, AB plus BC is not equal to AC. Similarly, AC plus AB not equal to BC. Next one, we can take it AC plus BC not equal to AB. See, from these now, we can say that sum of any two is not equal to the third one. Then what you could say, yes, the given points are not collinear. Yes, the given points are not collinear. That you have to talk. That's all. Not collinear. Have you understood, Vaibhav?
Yes, sir.
Right. Now I'll give you a problem now. Please do it. Check whether these are the vertices of an isosceles triangle. What you are supposed to take it? You have to draw a triangle sample and name them A, B, C. Mark them as A, B, C. And this point, this is A, this is B, and this is C. You take all this A, B, C. Find the length of AB, find the length of BC, find the length of AC. Then check it out whether they satisfy isosceles triangle. The condition is isosceles triangle. Any two sides should be equal. Whether they are satisfying any two sides are equal or not. Are you clear? Try to do this one. Can I do now?
अरे यार
Vaibhav, are you doing?
yes sir, yes sir.
Apply the concept of distance formula. You can use it either x2 minus x1 whole square plus y2 minus y1 whole square under root, or x1 minus x2 whole square plus y1 minus y2 whole square. Even you can take either that concept or this concept. Anything you can take it.
Sir done. Sir done.
So what is the value of AB?
Sir 5 minus 6
Okay, you
whole
answer.
square minus 2
5
minus
minus 6
2
whole square
minus 4 whole square.
minus 2 minus 4 whole square, right? Okay,
Yes sir.
5 minus 6 whole square, which is minus 1 whole square, and plus minus
Minus 1 whole square plus minus root minus 6 root whole square minus into 37x.
root 37. Am I right?
Yes sir, yes sir, yes sir.
Then BC. What is the BC value?
6 minus 7 whole square plus 4 minus whole
4 minus or minus 2?
2 minus 2 whole square
1 square,
uh,
then 6 square.
6 square.
Root 37. Got it?
Yes sir.
What about AC?
So 7 minus 5 whole square plus minus 2 whole square is equal to root under 2 whole square plus 0.
Got it?
Yes sir.
So from this, AB is equal to BC. So AB is equal to BC. These two are equal. So according to the definition of isosceles triangle, if any two sides are equal, that triangle ABC will be called as an isosceles triangle. Am I right? Are you clear? So if any two sides are equal, that triangle is called as an isosceles triangle. Next. Now, in a classroom, four friends. In a classroom, four friends are seated at the positions A, B, C, D. A, B, C, D. Now tell me what is the position of A, Vaibhav?
Yes, sir.
What is the position of A?
Sir, 0, comma 4.
3, comma 4. 3 units on the
3, comma 4.
x-axis and 4 units on the
Yes.
y-axis. 3, comma 4. What about B?
Sir, 7 by 6. 7, comma 6.
6, comma
6,
7.
comma 7.
6, comma 7. First x-axis, then y-axis. Then what about this one?
9, comma 4.
Right, very good. And D point?
6, comma 6, comma 1.
Okay. Now what he is telling that A, B, C, D are shown in the figure. Champa and Chameli walk into the class, and after observing for a few minutes, Champa asked Chameli, "Don't you think A, B, C, D is a square?" Chameli disagrees. Using the distance formula, find which of them is correct. Okay. Now using the distance formula, we are supposed to find that whether they forms right angle sorry, a square or not. Now I'm taking the total question right now. Just a second. Are you understanding what I'm giving you lesson?
Yes, sir.
Okay, very good. Okay. Now we have marked all the points. What are the points? Let us write all the points what we have done it. Now A. Solution. Point A we have marked as 3, comma 4. And B point we have got it as 6, comma 7. And point C we got it as 6, comma 1. And point D we got it as 9, comma 4. Now what is saying that Champa and Chameli they are walking to that. So there is an argument between them. So the argument what it says that Champa asked Chameli. Champa is saying that ABCD is a square. So but Chameli is saying that no. But the question it is that it is given to us using the distance formula whether they forms or not. What is that? Whether they forms. What is that? They forms a square or not. Okay, let us take a square. Mark all these points first. Or quadrilateral. You can think of a quadrilateral, you can take it off. See, you mark it in a cyclic order. People have a tendency, they will take it A, B, C, D. They will take zigzag. So that obviously the problem will be arises. What is that? They will not get the answer. Okay. Now we are moving to this one. Now, first of all, we are going to find the value of AB. So same distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. Say like time being, I'm writing x2 y1, x1 y1 and x2 y2. Same formula, please write it x2 minus x1 whole square plus y2 minus y1 whole square. At least once you are supposed to write the formula, or if you write all the ways the formula, then additional mark, at least that it is marks they will give full-fledged. So now, when you are taking x2 minus x1, 6 minus 3 whole square plus 7 minus 4 whole square. So 6 minus 3 whole square, which is 3 square plus 3 square. So root 9 plus 9, root 18. So root 18, we can write it as 9 into 2. So 9 into 2, which is 3 root 2 units. 3 root 2 units. Now, similarly, we have to go for BC also. BC, same thing, x1, y1, x2, y2. So then you can take it off 6 minus 6 whole square plus 1 minus 7 whole square. However, if you are taking, answer will become. Then, if these points, what we have located are correct, ma? 1 second, be on the line. Sorry, we have taken, I think so, wrong points. This is D. This is C. Now it is correct. Now, it is 6 minus 3 whole square and 7 minus 4 whole square. Correct. Now it is correct. 6 minus 9 whole square and 7 minus 4 whole square. 6 minus 9. So minus 3 whole square and 3 whole square, which is root 9 plus 9, root 18. Root 18 is 3 root 2 units. Are you following me?
Yes, sir.
Then CD. CD also same thing. Take the points, this one. So what you can write it? 6 minus 9 whole square plus 1 minus 4 whole square. So 6 minus 9 whole square minus 3 whole square plus minus 3 whole square. So which is 9 plus 9, root 18, same thing, 3 root 2 units. Now the left one is AD or DA, whatever it is. AD or DA, you can take it off. AD, what you can write? 3 minus 6 whole square plus 4 minus 1 whole square. So what we can write it here? Minus 3 whole square plus 3 square. So which is root 9 plus 9. Root 18, same thing, 3 root 2 units. Now, from these observations, AB is equal to BC is equal to CD is equal to DA. So all the sides are equal. Now, Vaibhav, one question for you. Can we say now this ABCD forms a square? All the sides are equal.
Yes, sir.
Can we say?
Yes, sir. Yes, sir.
No. We cannot conclude with this one. Because in a rhombus, in a square, the concept is all the sides are equal. But when it comes to the rhombus, the diagonals are not equal. But when it comes to the square, the diagonals are equal. So now, along with these sides, we are supposed to find the lengths of AC and BD. So now let us take the points. The point A, 3, 4 and 6, 1. For A, 3, 4. And the point C is 9, 4. Are you understanding? 3, 4 and 9, 4.
Yes, sir.
We are supposed to find the distance between them. So now 9 minus 3 whole square, then 4 minus 4 whole square. So which is 6 square plus 0 square. So 6 square plus 0 square is 6 units. Then let us take BD. What is BD here? BD is 6, 7 and 6, 1. Same thing. Apply the concept of that one. 6 minus 6 whole square plus 7 minus 1 whole square. So what we can get it 6 square, 0 square plus 6 square. They are also 6. These both are equal. So lengths of the diagonals AC is equal to BD. They are also equal. So in a quadrilateral, if all the sides are equal and as well as the diagonals also equal, then we can conclude that the given quadrilateral is a rhombus. Is a rhombus, sorry, is a square, because the diagonals also equal. If the diagonals are not equal, then we can say that it is a rhombus. But here diagonals are equal, so then it is a square. Do you understand, ma?
Yes, sir.
Next, I'm going to give you another problem. See, these type of tens are like problems, especially trigonometry and here and all, compulsory example sums, including optional exercise, you are supposed to learn. Now coming to this one, figure 7.6 shows the arrangement of desks in a classroom. Ashima, Bharati, and Kamala are seated A 3, 1. Now B 6, 4, C 8, 6 respectively. Do you think they are seated in a line? See, if you join using the scale, if they form a straight line, then this is one conclusion, then they are collinear. But joining the line, this cannot give the complete answer. This is just one idea of getting that they are collinear or not. But if you want to know that they are collinear or not, you are supposed to take all the points. Then after taking the points, you're supposed to find AB, BC, AC. Now sum of any two results the third one, then they are collinear. Now it is clear AB and BC when you add them is equal to AC. So 3 root 2 plus 2 root 2 which is 5 root 2 which is AC. Therefore they are collinear. They are seated in a line. So collinear concept is that one. Question number 4. Find a relation between x and y such that x comma y is equidistant from this point. Say x comma y. So it is an unknown point P. P x comma y. This is equidistant from A and B. It means you join PA and PB. So he is telling that PA is equal to PB. So when you are taking PA is equal to PB or AP is equal to BP, you have to apply the square root concept. So but before that itself, if you are squaring on both sides, now again no need to write the square root. So this problem, this type of models are very, very important. So now AP square is equal to BP square. Find the distance between PA and find the distance BP and expand it. Left side, expand it on right side. Say on look at a glance, x square y square all will be cancelled. Then minus 14x minus 6x minus 2y minus 10y 49 plus 1 50 25 plus 9 34. So by resulting that x minus y is equal to 2 will be the answer. So this is a required relation between x and y. Do you understand, ma?
Yes, sir.
Now next one. Find a point on x-axis which is equidistant from the points 6, 5 and minus 4, 3. See, the same type of this question, x, y type. But here it is given that clearly the point lies on y-axis. The point lies on the y-axis, it will be in the form of 0, y. So same thing, you take it, the point is P. So P is 0, y. From this point, now there are the two more points which are equidistant. Maybe it will be here on the y-axis like this, or maybe one is this side, one is this side, or maybe here, here. So anything could be possible. So take that PA is equal to PB. And squaring on both sides, PA square is equal to PB square. Apply the concept y is equal to 9. Now the question is that find the point. So the point is 9, 0, 9. If you write, if you do not write this one, out of 3 marks, half mark out, 2.5 mark only will be awarded to you. Because the question is that find a point. Yeah, and even 9, 0, sometimes they'll do mistake. Got it? So now, based on these example sums, you please do one question now. Question number 7. Can you do it now? Vaibhav, please do the question number 7.
Okay, sir.
So, right. Okay, all right. So now see the question now. So you just follow me and check it out whether you have done it or correct or not. Here, I'm taking the XY axis. So this is X, Y, X dash, Y dash. Now he's telling that find the point on X axis. So let us suppose taking that point on X axis. See, now what I'm going to take it, now 2 comma minus 5, 2 comma minus 5 plus and minus might be here, 2 comma minus 5. And minus 2 comma 9, minus 2 comma 9 might be here. See, find the point on x-axis. X-axis. See the point on the x-axis anywhere on the x-axis. So you can take on the positive side, on the negative side, but it is on the x-axis. So now you can take here. Now what is trying to say? It is equidistant from the x-axis. These points. Now take this is P, marking A, B. See, let the point on x-axis is x comma 0. Now it is given that the distance between the PA, PB both are equal. So squaring on both sides, PA square is equal to PB square. Say apply the concept, the distance formula, root over x2 minus x1 whole square plus y2 minus y1 whole square. So when you are taking on the left side PA value, so PA, see P point which is x comma 0 and 2 comma minus 5, and PB, so which is x comma 0 here also, and here minus 2 comma 9. Now you can take this one x1 y1 x2 y2, x1 y1 x2 y2. So now PA square is equal to PB square. Again, square root is not required to write it. Now if you apply that one, 2 minus x whole square minus 5 minus 0 whole square, then minus 2 minus x whole square, 9 minus 0 whole square. So now 2 minus x whole square plus 5 minus 0 whole square. Now please try to expand it. 4 plus x squared minus 4x plus 25, which is equal to 4 plus x squared plus 4x plus 81. Now 4 gets cancelled, x squared also gets cancelled. Now minus 4x, you please carry to the other side, and 25 minus 81, which is equal to 8x. Then from here, the point minus 56, which is equal to 8x, then x is equal to minus 56 by 8. So minus 7. So therefore, the point on the x-axis, it will be x comma 0. It will be minus 7 comma 0. So now the point might be here also. Vaibhav, have you understood the point minus 7 comma 0?
Yes, sir.
But you got plus 7 comma 0.
Yes, sir. Yes.
Carefully you are supposed to do it. Now next one. Find the values of y for which the distance between the points is 10 units. Say distance between them is 10 units. What is that? Find the values of y for which the distance between them. So the distance PQ, which is equal to 10, squaring on both sides. Squaring on both sides, which we can get it, PQ whole square is equal to 10 square. So PQ whole square, what you can write it? 2 minus 10 or 10 minus 2. Whatever the way, if you write it, no problem, that answer will be okay, which is equal to 100. Then 2 minus 10, which is 64, 8 square. Then here, don't do hurry anything expansion. See minus, when you take it out, minus whole square. So plus, so 3 plus y whole square, which is equal to 100. Then 3 plus y whole square is equal to 100 minus 64, which is 36. And square, if you send the other side, square root, 3 plus y is equal to square root of 36, which results plus or minus 6. So now 3 plus y, once you take plus 6, and 3 plus y, once you take minus 6. 3 plus y once you take plus 6, and 3 plus y once if you take minus 6, then y is equal to 6 minus 3, which is 3, and y is equal to minus 9. Therefore, the values of y will be 3 or minus 9. See, sometimes they will do mistake. Children, you have to remember one thing. Here it is when you're expanding, it is a quadratic equation. So quadratic equation definitely it consists two roots. So for the two roots, you are supposed to work. Clear? Fine. Now I'm moving to the next problem. Now, question number 6. What is that? Just I'll give you a brief. Name the type of the quadrilateral formed if any of the following points are given reasons to your answer. See, first question, if you take it A, B, C, D, you mark it as A, B, C, D. Now you take a quadrilateral, you mark A, B, C, D in a cyclic order. Don't mark A, B, C, D like Z shape. And try to find the value of AB and try to find the value of BC, DC, AD. If all the sides are equal, then go for diagonals. Then, so if they satisfy the conditions, then we could say the required. Now I'm going to give you what are the conditions. Number one condition. Number one condition when you take it for square. For square, all the sides AB, BC, CD, DA, they should be equal. Apart from that, the diagonals also should be equal. For rhombus, so same thing, AB, BC, CD, DA equal, but here AC should not be equal to BD. For rhombus over for rectangle. So for rectangle, we know that opposite sides are equal. So AB is equal to CD, comma AD is equal to BC. And also the diagonals also should be equal. AC is equal to B. Then number 4, for parallelogram. Parallelogram also same thing. AB is equal to CD and AD is equal to BC, but the diagonals are not equal. So for parallelogram, we are talking about the with respect to sides. So with respect to lengths, so the diagonal lengths are not equal. So AC not equal to BD. So if any one of them they're satisfying any one of these four conditions, then what we could say that respectively we could say if they satisfy this one, that they forms a square. If they satisfy this one, rhombus, then rectangle, then square. So parallelogram like that. And if they do not satisfy any one of these condition, other than this one, what we have left kite and trapezium. So kite, say kite, what you could say adjacent sides. For example, if you take A, B, C, D. If these two are equal, then automatically we could say it is a kite. In the kite only this kind of property will be there. So if they satisfy these conditions, then it is a kite. Okay, even if you want to check for diagonals, you can check for the diagonals also. Got it? Next. The balance sums from the exercise now. If you look, see, if Q 0, 1 is equidistant from the P and R, so then Q is equidistant. You take it Q, P and R. So QP is equal to QR. So squaring on both sides, QP square is equal to QR square. Find the values of X. So if you substitute the formula, distance formula, then you will get the value of X. The next question, which is the last one from this exercise. We have done already the example model. Anyhow, look at this one. Now find a relationship between the X and Y such that the point X comma Y is equidistant from the point points 3 comma 6 and minus 3 comma 4. So now let us take this is P. So from the point P, now A, P. So x comma y and 3 comma 6 and minus 3 comma 4. So what you could say, PA is equal to PB. Squaring on both sides. PA square is equal to PB square. Then what you could say, the formula if you apply x minus 3 whole square plus y minus 6 whole square, which is equal, then x minus or minus 3, x plus 3 whole square plus y minus 4 whole square. Now try to expand using the a minus b whole square concept. So x square minus 6x plus 9, y square minus 12y plus 36, which is equal to x square plus 6x plus 9, y square minus 8y plus 16. Now try to cancel the terms if possible on the both sides, from the both sides. Now x square cancel. Now y square also cancel. Plus 9 cancel. Is there any other terms? Minus 6x but plus 6x. Minus 12y minus 8y. 36, 16. So then your wish you can carry minus 6 to other side. Okay. 0 is equal to 6x plus 6x. Minus 8y plus 12y. Plus 16 minus 36. Now, which you say 12x plus 4y minus 20, which is equal to 0. You have to divide with the 4, then you will get 3x plus y minus 5 is equal to 0. See, the question it is that what is asking? Find the relationship between x and y. So we are finding the relationship between the x and y. What is that? 3x plus y minus 5 is equal to 0. This is the relationship between x and y. See, the question actually it is given that find the relation between x and y such that the point x comma y is equidistant from these points. And we have applied the concept of distance formula root over x2 minus x1 whole square plus y2 minus y1 whole square. Please write the formula everywhere. Wherever you are using the certain formulas and the please write it. This is totally the concept of distance from the coordinate geometry. Okay. So with this problem, today's class I'm going to wind up. So far, if you see the briefly what we have learned it, see we have learned about that 9th standard, the coordinate geometry. In the coordinate geometry especially was developed or given by René Descartes, French mathematician, and on behalf of his name only that it is called as coordinate geometry, René Descartes Cartesian system, right? So René Descartes Cartesian system, and we are learning x comma y. X is called as abscissa and y is called as ordinate. And
Yes.
from that, we from the system we know that the two x and y axis are dividing that plane into 4 parts: quadrant 1, quadrant 2, quadrant 3, quadrant 4. And also we are marking like this x comma y based on that only. X axis first, y axis next. Now these are called, first point x coordinate is called abscissa and y coordinate is called ordinate. And in this class 10th standard we have learned the distance formula. The distance formula root over x2 minus x1 whole square plus y2 minus y1 whole square. And based on that formula, then we have done the questions relevant to that collinear and types of triangles and types of quadrilaters and the relationship between the x and y and unknown points on x-axis and y-axis. So these are the problems are very, very important. There are 4 or 5 models only there. So these every model wise, if you learn these problems, then it is very easy to do. And at last, I would like to tell you one thing. In the board exam, they will concentrate the type of questions which are lies on x-axis, which are lies on y-axis, or this type of model, or this diagram type of questions, and collinear concepts they'll concentrate. Are you clear,
Okay.
Vaibhav?
Yes, sir.
So for better results, keep practicing. All the best. Thank you.
Thank you, sir.